We are now diving into one of the most important discussions we are going to have here in our IP addressing and subnetting session today. It's about determining the NFLB, so the network, first, last, and directed broadcast address for IPv4 addressing. So if we recap right now where we are, we know that we have 65,536 subnets over here. We know that each one of these subnets can have 254 IP addresses within them, each of them, right? What else do we need to know, though? Well, it'd be really great if we knew how to figure out what the actual network ID is, what the directed broadcast address is, and what all the usable IP addresses are for any subnets that we have. So what we want to teach you now is how you can turn around and figure out what is the network address, first usable address, last usable address, and directed broadcast address for any subnet that you have. And what we basically do is we figure out the block size. We figure out the block size of what is going on, and then we can figure out all the addresses in that particular block that we're dealing with. So let's go ahead here and show you method version 1. Okay, so I have a version 1, version 2 method. The only difference is based on the numbers you're looking at. So for example, version 1 works really, really well when you are giving a slash subnet mask, all right? Slash subnet mask. But version 2 works really, really well when what? When you are dealing with a slash notation. Not slash notation, dotted decimal notation. That's what I was looking for. Right there. So 255, 255, 255.0. So I'm going to show you both using the exact same example. So that way there, if you can learn both, then you can swap back and forth between the two on the exam. If you only learn one, then it simply means you're going to have to convert the subnet mask to the format that works for version 1 or version 2. So for example, if you get really good at version 2 and that's the one you want to use, and they give you a subnet mask like /24, you're going to have to convert it to decimal first and then go ahead and use version 2, okay? But if you knew version 1, then you wouldn't have to convert it to decimal. All right, so what do? We want to determine the progression based on the subnet mask. And this is a really key skill here for everything we're going to do going forward. Determine the progression based on the subnet mask. So it's all about the subnet mask. Doesn't matter the IP address. In the end, what matters is the subnet mask more than anything else. So you immediately look at the subnet mask and you say, we got a /24 here in this example. So what is that in binary? Well, that's really easy. It's 24 ones followed by 8 zeros. So that's not hard to do. And would I really write out all these ones and zeros on an exam? Absolutely not. Instead, I shortcut what I'm looking at. I might turn around and write down 8, 8, 8, and then the zeros. Or, for example, 8, 8, 8, 8, 8, and then I might put the ones there. It depends on how many I need. You're going to see me start doing that in today's session when I start showing you shortcuts to make you faster. Okay, but also if you just memorize some numbers as well, you don't even have to go this far anymore. And so I'll give you those specific numbers as well. All right, so now what you do is you find the very last one. The very last one, where is that? It's right here. Circle it, right? Circle it mentally. You don't have to actually physically circle it, but where is it? There it is, right? So the next question is, what octet is that in? Well, this is octet 1, 2, 3, 4. So it is in octet number 3. Okay, octet number 3. Okay, and then what is the decimal value of that exact bit position? I'm not asking you to add anything here. I'm just saying, what is the decimal value? So this one is 128. This one's 64. This one's 32. This one's 16. This one's 8. Wait, I messed up there. This one's 128, 64, 32, 16, 8. There it is. 4. This one's 2. And this one is 1. So its value is what? Its value is 1. Okay, don't even add them. Just what is the value of that exact position? It's a 1. Okay. This is the number that you are progressing by in that octet. This is the number you're progressing by in that octet. What does it mean? It means I'm counting by 1 in the third in this case. So with a /24, you're always counting by 1 in the third. Always, no matter what. /24. Okay, so what does that actually mean? Well, what was our original network? Our original network was 10.0.0.0/8, right? That's what it was. We got to /24s. So what is the very first address? The very first address is going to be this exact same number, but now it's a /24. Okay? Now you count by 1 in the third. So 10.0.0, 10.0.1.0/24, 10.0.2.0/24, 10.0.3.0/24. See, I'm counting by 1 in what? The third octet. I'm counting by 1 in the third. And what are these? Network IDs, network ID, network ID, network ID, network ID. Now, how many are there? Well, if you remember, if you go from an 8 to a 24, there's 65,536 network IDs here. I am not going to write them all out. I am not going to do it. You can't pay me enough to do it. No, I've just shown you how to figure out all the network IDs. So, are you able to now figure out what are the addresses in that network? Sure, of course, because, for example, take this one right here. Right? So you have 10.0.3.0/24. You now know, right, the next network ID is what? 4.0. Right? So, network ID, network ID. Okay. So, what would be the very first usable address in that subnet? Okay. First address. What would be the directed broadcast address? Okay, it's one less than the next network ID. So it would be 10.0. Oh, no. Okay, well, wait a second. There's something we're not allowed to do in this world. It's illegal. And that is roll back the odometer on your car. All right. For example, if your car was at, let's say, 10,000, or let's do this instead. Let's say your car was at 7,648. If you wanted to roll it back, you'd go 7,646, 7,645. Wait, what did I say? That was 8. I can't even count backwards. 7, 6, okay? Rolling back the odometer. Eventually, you get to 7,600. Eventually, you get to 7,600. What happens in this case? Well, then this has got to roll back to what? 599, right? 599. Just like if you were at 10,000 and you wanted to roll it back, it'd become 0999, right? And one more 9. One more 9. So same idea here. Let's roll this back to a 3. And then let's roll the 0 back to what? A 255. Right? Because our value goes from 0 to 255. Okay, so that's your directed broadcast address. And then the last address is 10.0.3.254. There you go. So that's all that you're doing. Now, why is this important? Because there are many different types of questions you can get on this exam. Right? You remember in our last session when I showed you a question about figuring out which of these match? Right? Well, being able to figure that out on the exam might require you to what? Figure this out. So that way you know if the address actually falls within that range, because now you know the range here. What if you ended up with a diagram like this and they were asking you to figure out addressing? Or you had a diagram like this and they were asking you to figure out what in the world the problem was. Again, figuring out what are the valid addresses in that subnet first might be really important. Right? Looking at a routing table and figuring out which one will be used to actually forward the traffic. Right? Another, maybe skill you got to do, but you got to figure out the range of addresses first in order to ultimately get to that answer. Let me show you version number 2, and then we're going to do some examples together. So in this case here now, right, the only difference is that we're given the dotted decimal version instead of the slash notation. Now, 255.255.255.0 is a /24, okay? It is. So /24. So what does that mean? It means that you could, if you know that, you can just go ahead and use /24 and use version 1 if you want to. Just like if you learn this method and you like this method better, then if you had a /24, you just convert it into these values instead, dotted decimal. Or you learn both, and then you don't have to do any conversion at all. Determine the progression based on the subnet mask. So same process here, except, right, we're using decimal numbers to figure this out. So in this case, what do? Find the last octet with a number greater than 0. So this is the last octet with a number greater than 0. Okay, that's the one we care about right now. So what octet is that number in? That's the third octet. Right? And then take the number 256 and subtract from it 255, the number in that octet. So take 256, subtract the number in the octet, and that's what you're going to be progressing by. 1. So that's the number you're progressing by. So it's the same answer, right? Because /24 is 255.255.255. Okay, so you get to the same answer when it's all said and done. We're progressing by 1 in the third octet. It's just that in this case, we're using decimal numbers versus binary numbers. So same idea here, right? So for now, right, we started off at 10.0.0.0 and then 255.255.255.0, right, which is /24. And that'd be the first one. And then you're counting by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, there's 65,536 in this scenario, so I'm not writing them all out. But these would be all the network IDs. So this allows you to figure out the network IDs. And then from there, you can figure out what? You can figure out in between, right, what is the first usable, last usable, directed broadcast address. All right, so let's try this for a second. Let's go ahead and just pick an IP address. So I have nothing written down here. We are going to play Stump the Instructor. How's that sound? Everybody want to play that today? So I want somebody to chat in right now an IP address and a subnet mask. And what we're going to do is we're going to figure out exactly what the network ID is for that IP address, what the directed broadcast is in that subnet, and all the usable IP addresses. All right, so we've got 192.253.20.125/22. So what is our goal here? Our goal is to figure out, hey, what is the network ID? What is the first usable address? What is the last usable address? And what is the directed broadcast address for this IP address? So this is the IP address. That is the subnet mask. So this belongs to, let's say, some PC. But we want to know right now, what network do they belong to? Right? By just looking at that right now, folks, I have no idea. I have no idea. I really don't. Right? I need to do the math to figure this out. And then I want to know every single IP address that is also in the same subnet and then the directed broadcast address for that. So let's go ahead and do that using exactly what I just taught you. So look at the subnet mask /22. So the /22 subnet mask, what are we doing? Well, you would have, for example, 1, 2, 3, 4, 5. Okay, I'm not going to write all the ones out. Instead, what I'm going to do is I'm going to say we got 8 ones followed by 8 ones, right? That's 16, 17, 18, 19, 20, 21, 22, 23, 24, and then 8 more zeros, right? Because what do I care about here? Find the last one in that subnet mask. So there's 8 ones. Don't write them all out if you don't have to, right? Only write out the ones that matter. So we've got one, this is so 16, 17, 18, 19, 20, 21, 22, right? So what position is that? So that is going to be, if we have our chart, which would be good to have written down, 128, 64, 32, 16, 8, 4, 2, 1, right? So we've got 128, 64, 32, 16, 8, 4. It's still 4. So we are 4. So we're counting by 4 in the third octet. And remember, we're not adding them together, right? It's just at what position is that? That is the decimal 4 position compared to binary, right? We got 1, 2, 3, 4, 5, 6. Right? 4. Right. So now what does that mean? We're counting by 4 in the third. So go to the address, write it down, 192.253.0. Since we're dealing in the third, 0 out the third and 0 out the fourth. So if you're working in the third, 0 out the third and the fourth. If you're working in the fourth, only 0 out the fourth. If you're working in the second octet, then you 0 out the second, third, and fourth. Okay? So right now, third, 0 out the third and the fourth. And then put your /22. This is one of the network IDs. It's one of many network IDs for /22. Right? I don't care about them all in this scenario. What I care about is figuring out network first, last directive for this address. Right? So if we're now counting by 4, then what's the next network ID? 192.253.4.0/22. That's another valid network ID for a /22 subnet mask with this addressing. Okay, the next network ID is 192.253.8.0/22. Right, now would I be writing all this out? Of course not, right? It'd be 0, 4, 8. We got what next? 12. Then what? 16. Then what? 20. Then what? 24. Then what? 28. Okay, stop. Stop. Why am I stopping? Because you see 20. There it is, right? It's right there. So what do we know? We now know that this lives in this network because that number would fall between here and here. We know it lives in here somewhere. Brett, doesn't matter, man. It doesn't matter. I'm serious. Because I know that's a Class C address, but you can actually have Class C addresses with subnet masks smaller than 24, 23s, 22s, 21s by combining multiple Class C networks together. It's actually called supernetting. Yeah, it's the reverse of subnetting. So you're not wrong. It is possible, not common, but it's possible. Yeah, it's possible. Okay. So this right here would be a combination of multiple Class C networks combined together to create one network. Instead of subnetting, you're going the reverse direction. Yeah, that's what that would be. So it's okay. It's okay. Yeah. Just want to show you it still works out. That's why I didn't skip it. I'm like, I saw that as soon as you I saw it as soon as you typed it in. I'm like, hey, it's not typical, but it would still be valid if somebody wanted to do it that way. Right? So now in this case, what do we want to do? Right? We want to figure out everything else. So my network is 192.253.20.0/22. What's the directed broadcast address? Well, it's going to be one less than that one. One less than that one. So it's going to be 192.253.23.255. So the last usable is 192.253.23.254. And then the first is 192.253.20.1. So this address lives in this network with all of these other addresses, and that's their directed broadcast address. And there you go, without using a calculator. Is that what we got? That's what I got. 20.1, yep. 23.254, yep. 23 to 2, yep. There we go, we got them all. It's exactly what we calculated right here. Now, if your brain hurts, that's perfect. It's good. Nothing wrong with that. You know why? It shows you're paying attention. It shows that your brain's trying to process it, struggling a little bit, with a little bit of practice, a little bit of homework, right? It'll all become clear. My brain hurts many times when I'm learning new things. So it's not uncommon there, Andrew, that your brain would hurt, okay? I learned this stuff over 25 years ago. And I'll be honest with you, I almost gave up. My brain hurt. It exhausted me. It frustrated me. But I didn't have somebody teaching it this way to me. Right? I was doing it in a way more convoluted, complicated way where it was like I was either going to get it right or wrong. There was no like perfect formula for me that my teacher ever taught me. But I persisted. I got through it. But yeah, it takes a while. Right? And I'm glad today I didn't give up, that's for sure. So if your brain hurts, embrace that. You're going to be okay. You're going to be okay. And I'm here to help you out with that, okay? Don't panic. Steve, let's do it. 10.144.18.252. Oh, Steve, you're hurting me. You're hurting me, man. All right, /28. I already know this is going to be a lot of writing potentially for me. So, /28. We've got 8, 8, 8. That's 24, 25, 26, 27, 28, 29, 30, 31, 32. Right? What is the decimal value of that bit position? Well, working left to right, we got 128, 64, 32, 16. So we're counting by 16 in fourth. This is where you got to be super careful. So 1, 2, 3, fourth, right? Fourth octet now, not third, the fourth. All right. So what do? Since we're in the fourth, our first number is going to be 10.144.18.0 out the fourth, right? 0 it out /20. So this is one of the many network IDs. There are network IDs before this, and there are network IDs after this, right? I don't care about all of them for the exam. I care about the one I need, right? And so that's what I want to figure out right now. What is the network ID that's going to match this address? So if we're counting by 16, that means next network ID is .16. The next network ID is .32. All right. This is where things get really complicated for some people, because now it's, what's the next one? 48. Right? Okay. And you don't have time to panic about counting on the certification exam. So I'm going to show you a shortcut right now. You ready for this one? You got 128, 64, remember? 32, 16, 8, 4, 2, 1. What I want you to realize is that whatever you're counting by, so right now we're counting by 16, right? What does that mean? It means that I will eventually hit 16, obviously, and every other power of 2 after that. So I'll hit 32. I'll also hit 64 eventually. Eventually, I will hit 128. So I know I have to get up to what? 252, right? So I can jump ahead. And I can say, well, I got to get all the way up there. So forget about counting, right? So I can go 128, right? Because the rest, they don't matter. So let's go to 128. Now, another thing I want you to realize is that you'll also continue to increment, right? But you'll never increment by a value of 8, 4, 2, or 1. You'll increment by 16. But remember, you'll also eventually hit a 32, a 64. So what does that mean? It means that I could technically add right now another 32 if I wanted to this one. Because, right, it's still part of my counting by 16. 16, 32, I'll eventually hit 64, I'll eventually hit 1, right? So add another 32, and what do we got? We got 150 now, is that correct? Nope. Oh, 60. Sorry. We got 160. And right now in this particular case, I'm going to go ahead and add what? I'm going to go ahead and say, well, what if we try another 64? Is that still less than 252? Yeah. Right? If we add another 16 to that, what do we get? If I add another 16 to that, what do we get? Oh, we get 256. Okay, too high. So 240. 240 is a network ID. There you go. Okay? So you can do that if you want to. Right? Or, Nick says, what if we take 256, not 255, but 256, minus 16, potentially in this case? Right? Then you're counting backwards. So 240, oh, wait, yeah, right? If I'm counting backwards from 256, not 255, 256 by 16 backwards, right? That might be working out for you too. So whenever the numbers are really high, right, it takes a while to count. Now you can count by 16 if you want. 0, 16, 32, 48, 64. was it 80, 96, ones, see, right? I'm slowing down, okay? But the idea here is to keep in mind that there are multiple ways you can count. Count forward, you can skip. If you skip, remember that you can skip as long as the number is higher than what you're counting by, right? You can skip as long as it's higher, not lower, higher, like I'm doing here. I'm always using skips that are higher. Or you could even count backwards if you want to, from 256, right? So in the end, we figured out that there is a network ID 240 that is as close to that one as we can. So what do we got here? We got 10.144.18.240 is its network ID. Because the next network ID is actually going to be network 10.144.18.256. Wait, you can't do that, right? But if I add 16, it's 256. No, right? Now your odometer has to switch, right? So what happens here is 18 becomes 19, and this becomes 0. So that's the next network ID. So the next network ID is 10.144.19.0/28. Okay, so we got 240. So what is our directed broadcast address? 10.144.18.255. Our last usable address is 144.18.254, and then 10.144.18.241. So the network ID here is 240. Directed broadcast address is 255. 241 to 254 are the valid addresses. Let's confirm that. So yes, Steve, that was a lot of counting. Thank you. 241 to 254 with 240 is the network ID, 255 is directed. We got it. Awesome. All right, so why is something like this important? Right? Why do we care about being able to do this? Because I know some of you are sitting there going like, why? I like, give me an example why this matters. Okay, so what if I said this to you? All right, tell me right now. Yes or no? Look how close they are, right? 6, 46, 47, 48, 49. They're so close that on an exam, right, they have the same subnet mask, but are they actually in the same subnet? So how do you figure this out? Well, if you're a /28, 24, 25, 26, 27, 28, 29, 30, 31, 32. So we are counting by 16 in fourth. So what are we counting by? We got 0, 16, 32. Then the next network is 48. Next one's 64. So 46 lives in this network. 49 lives in this network. The network ID for this address is this. The network ID for that network is that. But you wouldn't know 100% unless you could figure out where each network ID was, right? So Andrew, those that are answering really quick may have a lot of experience with this already, right? You got to remember that, right? So some people here are experienced. They know a lot about subnetting. They already do this. They're here to prepare for the CCNA exam, get updates, gets tips, gets tricks. Okay. So many different people with different levels of experience. So it's okay. If you're not visualizing it right away, no, don't worry about it, right? You're going to come back and you're going to practice like they've all done in the past. And you're going to get to the point where you are going to be able to visualize it when it's all said and done, right? So don't put a lot of stress on yourself. It's okay. Yeah. Right. And there's patterns here. Like I'm going to show you some of them in a moment. But it's practice. It's doing it. It's working at it. I'm going to give you guys some stuff to work on in a moment. And I am here to help you behind the scenes. At any point in time, you need extra help. So don't give up on this. When you need help, you'll be able to email me directly, and I'll be more than happy to walk through examples with you. There really is no trick. It's about understanding the boundaries and everything else that go along with it. All right. So, for example, when I see something like a /29, right, because of experience, right, years of teaching, right, and knowing that /29, I'm counting by 8, then that means that I can just go ahead and know, if I'm counting by 8, eventually I'm going to hit 64, add another 8, add another 8, add another 8, right? And you can just quickly do that in your head and go, oh, there's the number. It falls in here and there, right? So that's why. That's why many people here can just do it really quick in their head because they know those boundaries. But with /29, I'll show you long form, 8, 8, 8. So we got what? 8 ones, 8 ones, 8, 24, 25, 26, 27, 28, 29, 30, 31, 32. So we are counting by 8 in fourth. Okay? Counting by 8 in the fourth. So if we're counting by 8 in the fourth, then we're starting off at 10.42.69.0. So counting by 8, 8, 8. Eventually I'm going to hit 64. And then we got what? 72, 80, 88, 96. Okay, I can stop right there, right? Look at that, 95. So make this a little bit bigger. We got 88, and then we've got 96. So this address falls in this network. So this is the network ID. So the first usable address would be 89, ending in 89. Last usable and directed broadcast. So directed broadcast would be one less than 96, so 95. And the last usable would be 94. So is it a usable address? The answer is no, because it's what? The directed broadcast address. That's the only reason why. It's because it's the directed broadcast address for a /29 network. So it's about repeating this process over and over and over again. Right now, I'll have some slides for you to work on that after. But some of the things to keep in mind, right? If you are a /24, you're counting by what? By 1 in the third. Counting by 1 in the third. Okay, but if you're a /25, what are you counting by? 128 in the fourth. If you're a /26, you're counting by 64 in the fourth. 127, you're counting by 32 in the fourth. If you're 128, you're counting by 16 in the fourth. If you're 29, you're always counting by 8 in the fourth. If you're 30, you're always counting by 4 in the fourth. So what does that mean if you're, for example, like let's say you're /23? What are you counting by? The /23, you would actually be counting by 2 in the third. The /22, you're counting by 4 in the third. The /23, you're counting by 8 in the third. The /20, I said 23 there, I meant 21. 21, /20, you're counting by 16 in the third. Right, with the /19, you're counting by 32 in the third. With the /18, you're counting by 64 in the third. And with a 17, you're counting by 128 in the third. And if you're a /16, you're actually counting by 1 in the second. What I want you to notice is you see they repeat. They repeat, right? And it's all because of going back to our chart, way back here. So for example, with this subnet mask, right, I'm counting by 1, because that's the 1 position, right, in the third. But here, that would be what? The 128 position. 128, 64, 32, 16, 8, 4, 2, 1, right? So you're 128 in the fourth. And then here, this would be what? 64 in the fourth, 32 in the fourth, 16 in the fourth, 8 in the fourth, 4 in the fourth, 2 in the fourth. Right? Go back here. What are you counting by? Right? If we go to the third octet, right? We're in the third octet. Well, in this case, you're counting by 16, counting by 8, counting by 4, counting by 2. And that's exactly what I was just writing down on that other page, right? So let's go back. Let's go here now. And over here, if we keep going, counting by 32, 64, 128, 1, 2, 4, 8, 16, 32, 64, 128. Repeating pattern. So those are the only possibilities for counting. Those are the only possibilities for counting and figuring out the network IDs. Why? Because the powers of 2, binary. So if you can remember that for example, if you have a 255 as your last number in your subnet mask, for example, like this, then you're counting by 1. If we go over here, right, 255, you're counting by 1. The difference is the octet you're counting in. 3, 2 versus 3. That's it. 2 versus 3. Right? If you've got a 128, whether the 128 is there or whether the 128 is here, you are counting by 128. It's just the different octet that you're doing the calculations in. Right? If it's 192, whether it's there or back here, or back here even, okay? We wouldn't go that far back, okay? But 192, right? Either in the second octet or the third octet or the fourth octet, right? In the end, you're counting by 64, right? And if it's 224, no matter what octet, you're counting by 32. If it's 240, no matter what octet, you're counting by 16. 248, 8, 252, 4, 254, 2. That's it. Those are the numbers. And so those repeating numbers, those patterns, you can apply those in the end to when you're doing the calculations. So, and that's what I wrote out here. Wrote it out by hand, but the chart, right, you can use that with your 128, 64, 32 when it's all said and done. So when it comes down to it, for example, if you have the IP address, /26, right? What are we counting by? Right? Well, /26 would be 255, 255, 255, 192, right? So 192s, we're counting by 64. Okay. But again, if you don't memorize that, that's okay, because you can always take this and go 1, 2, right? Again, I'm not going to put all the ones down because that would just take too long in the exam. 8 ones, 8 ones, 8 ones. That's 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, 64 in fourth. And there you go. So if you struggle memorizing those numbers and taking shortcuts, then this is perfect. I still do it this way on the exam. Even though I got all these things memorized, but I still fall back to having things where I can just quickly jot it down. So I still use this method myself this way. Some of the ones I can do in my head, like 28 for me is just an easy one. It's always like 4 ones followed by 4 zeros, and you're counting by 16 in that case. Anytime it's a 240, no matter where that 240 is. So I'm counting by 64, then I got 172.192.42.0. And then what's the next subnet? 172.192.42.64. Okay, there you go. So this is the network ID. So therefore, 63 is the directed broadcast. 62 is the last usable address. And .1 is the first address. There you go. I just figured it out. All right? So it's about practicing the process. And that's going to be the most important thing for you to do when it's all said and done.